So now in this video I thought we would take a circuit I made a long time ago. This is an old diagram, and go over it again. This is a good circuit for people just starting to learn transistors. This is the NPN bipolar junction transistor. The particular one I'm using, and the light's in a good position right now, is the 2N3904. So these numbers are kind of small. It helps to have a magnifier loupe like this to read them. And there you can see it pretty nicely. 2N3904. So with the bipolar junction transistor that starts with 2N, the pin layout is the left pin is the emitter, middle pin is the base, and the right pin is the collector when you're looking at the flat side. So we're going to swivel it this way, and now it matches what we see there. Collector, base, emitter, and we're not going to put it to the jumper yet. We'll talk about that coming up. We're going to set a voltage. And the circuitry here, it takes a voltage. You take away 0.7 volts. But in any case, it puts that voltage across a resistor. And based on that voltage and the resistance, it's going to let that amount of current through the collector down to the emitter. So from the positive side of the power supply all the way down to the negative side. It's going to set a current even as a load changes. So now, I'm going to set the voltage of the trim pot. We're dealing with a 5 volt power supply. And so the trim pot is a resistor. So it goes from the positive rail to the negative rail, as you can see there. And it also has a wiper on there, so that the wiper is the output. You can get a fraction of the power supply voltage. It's a variable voltage that you get out of it. And so you get a fraction of the power supply voltage though. So in any case, we will go to voltage here, and it's important that I decide what voltage I want. So I want 1 volt ultimately, but the transistor is going to drop about 0.7 volts. So what I'm going to do is, once I get a good connection here, so that jumper ends up connecting to the wiper there, is I'm going to turn this down to 1.7 volts, and that will make the math easy. So let's get to about 1.7 volts. Doesn't have to be exact, but there we go. That's close enough. 1.8. Well, we'll just get slightly more current than we would get if it was about 1.7 volts, and the transistor blocks 0.7 volts. So now we're going to put the transistor to the base of the transistor, the middle pin, to that jumper. So it's going to get that voltage. And we're going to put a 1 kilo ohm resistor to make the math easy. So 1 volt across a 1 kilo ohm resistor gives you 1 milliamp of current. 1 milli is 1 thousandth. So you got that voltage across there. You get 1 thousandth of that number in current. So we'll get 1 milliamp, even as a load changes. So now we have that there. And if we measure that voltage right now, so I'm going to get the voltage here. This is why I did this measurement without the transistor connected. You can see now we have a lower voltage. It's not 1.7 at this point anymore, because we have a connection to the negative rail that's helping pull it down. So we don't want to measure it without a load and with the resistor there. So I'm going to set the meter to measure milliamps of current, and with this meter, the red probe stays right there. I do have to go to milliamps right now. Now you got to be careful. You don't want to measure the power supply when you have it set to measure current, because a lot of current will go through. I do have this power supply limited though, so there you can see a 30 milliamps of current. It'll see a short circuit though and shut off. But if you measure like a battery or something, the current directly, it's going to put more current than the meter is designed to handle. So don't do that. But it doesn't limit current like it does voltage. So there you can see a little more than 1 milliamp of current. That's what we expect. Now, that is with a 1000 ohm resistor. We can take an LED, and there you can see it's the same amount of current. So that's in series with the transistor and the resistor. And we can take a 220 ohm resistor. Can't go too high in resistance, because then that will start limiting current more than the circuitry, and current will go down. So it can only provide so much power. But there we go. We got the same amount of current there, a little more than 1 milliamp of current. So now, later on we'll change the voltage to get a different current. For now, we're going to change the value of that resistor. So it's a 1 kilo ohm resistor. Gives us 1 milliamp of current. I'm going to grab a 510 ohm resistor. So that's half the resistance. So less resistance, more current. Pretty straightforward. So we'll still have about 1 volt across there. Now the load will have about 2 milliamps of current. So half the resistance, twice the current. Basic Ohm's law. So again, we are set to milliamps of current, and we will see that there we go. We got, twice the current. We can plug this, grab a 220 ohm resistor, and so 220 ohms is not a fourth and it's not a fifth. It's somewhere in between. Let's put that to the negative rail there. So I expect a little more than probably 4.5 milliamps of current right there. So it actually went up to 5. That's right. We're a little more than 1 volt. But in any case, there we go. It went up to 5 milliamps current. Now we're going to go to the other end of the spectrum. We're going to take a 2200 ohm resistor. So about twice the resistance of the 1 kilo ohm resistor. So with 1 volt, we should expect about 0.5, half of an amp right there. And there you can see, it's pretty much spot on, 0.5. And so now we're going to go back to the 1 kilo ohm resistor before we do the next part of this testing. Now we're going to change the voltage. So set the meter to measure voltage, and I want 2 volts across the resistor so that we get twice the current. And what we're going to do this time is take a jumper right there and go across there, because if we measure the voltage without a load, then it's going to be thrown off. And so before I just got rid of the transistor, this time we are just going to get the load there. So this will probably be a little more accurate even, because we actually have a load there. So we're still at our a little bit more than 1.7. Let's go to about 2.7. Turn the trim pot there. And we can be a speck below. There we go, 2.7, pretty much spot on right there. And so now we yank this again without that load. Now the voltage is going to be thrown off. So let's take a measurement of the voltage across the resistor now. It's only about 0.5, and over there 1.2. So it's thrown off because there's no load. But once we add a load, we already saw we do have the voltage. So let's set this to measure milliamps of current. So again, this is a 1 kilo ohm resistor, but now we're dealing with 2 volts. So when we measure the current, and again this meter, you can just leave current in that spot. We'll measure the current. So that's going up to the collector there. And I wasn't really clear about that earlier, but there you can see 2 milliamps of current. We can add, again, an LED. We can't add a whole lot of load though, because we're only dealing with 5 volts total at the power supply. But there we go. We got the LED up to the anode. Remember, you got to put these in the right way for them to light up. Still, 2 milliamps of current. And again, we can swap out the values. And so if you have a set voltage, you can adjust the resistance. And if you have a set voltage, you can adjust the resistors, or you can take the resistor value and adjust the current. So there we have half the resistance, so twice the current, whether we have an LED for a load or not. Right there, 4 milliamps of current. We can again do the resistor. The load doesn't really matter as long as it doesn't block too much power, which actually isn't terribly hard with only 5 volts at the rail. Let's try an LED and the resistor. We may dip too far. So yeah, it's still holding pretty good there. If I add another LED, then we will definitely not have enough voltage to hold that there. And there you can see that. So what we're going to do, is add more voltage. So we got 5 volts, and I'm going to pluck this stuff. Let's change it to 10 volts right there and raise it up. Now we got 10 volts at the rail, so that's going to throw off our voltage divider. It's actually going to be about 4 volts. So let's look at that, because we doubled the voltage going to the supply. So if we go here with the same resistor there, we should have about 4 volts at the trim pot. Let's make sure we get to voltage. That's the big danger with multimeters, is if you measure current, you forget to change it before you measure voltage, especially if you measure a power supply. This one's limited to 30 milliamps, so it would not damage this meter. But if the power supply doesn't limit current, that's how you can damage the meter. So let's take a look at the voltage. Since we have that complete, we can just measure it directly, and there you can see it's 5.32. So what we're going to do is turn this down until we get to 2.7 volts again. And so we're dealing with more voltage at the power supply, but the voltage that I set, I want the same that it was before. So that's close enough, 2.7 and a little bit more. And so with that 2.7 volts, let's go back to the 1 kilo ohm resistor, and we expect 2 milliamps of current again. Now we got to set this to measure milliamps of current. So we have more power at the supply though, and so we saw 2 LEDs in series was too much, so 2.13 milliamps. We will add 1 LED here. Remember, long lead the anode needs to go towards the more positive side, short lead the cathode towards the more negative side. It's holding steady. We'll add another one, and some of these LEDs got more views than others, so they may not be as bright as one that is the same color. Green are naturally brighter, so I think these red ones might have a different brightness, but you can see they're passing the same current. And I think we can even add a 4th one. So we can add a lot more load. So they're all in series. So that finally did it, that 4th one. But we just do 3 right there, and we can bypass another one. So you'll just see 2 of them light up, or bypass the other one because they are in series there. So ultimately, the load has a set amount of current through it, but you need to have enough power, enough voltage, I should say, to be able to provide that current through the load, plus your losses through the transistor and the emitter resistor and whatnot. But for the most part, you have the basic property of, if you're using an NPN bipolar junction transistor, the current it's going to let from the positive supply to the collector, which is also what goes through the transistor and the resistor, is a voltage you set at the base minus 0.7 volts. That goes across the resistor. The value of the resistor then sets the current after there. So you got a number of ways to set it, but once it's set, that's the current you can expect, as long as the power supply has enough voltage to give that current through the particular load you're using. So in any case, hopefully you found that interesting. I'll try to make an updated diagram on this circuit, and so this is kind of a reminder to do that. Plus I got a little more experience of stuff I should add to the diagram. So I hope you enjoyed this bonus video. Thanks for watching. I will see you in the next video.